folks, this week's lab is going to go into detail of the scientific method, and I'm going to speak about it kind of more in layman's term in some respects, because I think it's a little easier to understand the scientific method if we can look at how we apply it in our everyday life, and then take it to the scientific level when we actually do our experiment this week with the beans. So basically, to think about it, it's the process of science. Science is all done through this scientific method process. It's a step-by-step process. Many books kind of show it in different steps. Some books have very specific detailed steps, and some have very few steps. But basically, it allows us to solve some type of problem or answer some type of question. And so we are trying desperately to figure out an answer to those questions. And by doing that, we go through these steps. So this is kind of the basic. I put numbers here by some of the basics that we do, but obviously there's some kind of like sub-steps and little wiggly room in between. First of all, we have to have some type of observation. Then we do some research maybe about that observation, and sometimes then we come up with a question. So we define what a question might be. From there, we might form some type of hypothesis, and a hypothesis we'll talk about a little bit further. And then from our hypothesis, we might kind of come up with this idea of, well, a prediction. We might kind of make a guess and predict what would happen. And then we do this experiment. So we actually test our prediction. We experiment on something. And then we would collect our data and analyze it. And then from there, we would draw some conclusions. Now, many times in science, we might get through this process where we go through observation, we go through a hypothesis, and maybe we start testing things. So we do this experiment and something needs to stop. And when we need to stop, we might need to revisit our hypothesis or our question or even our method of how we're doing the experiment. And then we might continue that, or we might actually change things. So sometimes that happens, and then they'll again collect data and do conclusions. And even when we collect data and get to conclusions, we might go all the way back to this kind of question and hypothesis and start to kind of tweak it and do it all again. So a great example of this is right now, scientists are working really hard with many companies to trial a vaccination for COVID-19. And as most of you may have heard, if you kind of listen to the news or see it on media outlets, that we are in this test phase, which is actually quite incredibly quick for any kind of drug to ever be tested this quickly, and tested on humans for that matter. And you may have heard the Oxford University just recently stopped their trial because they had a person that they were experimenting with who had some severe side effects. And so clearly they were at this point where they were experimenting, they halted, did some revisions, and actually just as of yesterday, I believe, they have restarted this experiment again and continued with the trials. They might analyze all this data in the end and come to the conclusion that this doesn't really work right, and then they would have to go back to square one again. Lots of times this happens in science, lots of times this happens in the pharmaceutical field. And I just want to express how insanely quick this is happening, that they are pushing through the testing for a lot of this. I know people are working hard, but just keep your eye open when you're thinking about things like that. So our first step was observing. So let's say we're observing. When we observe, obviously we're using our five senses. We're observing a noise, a sound, a smell, something tasting, feeling, hearing, knowing. So we're kind of observing the world around us, and we might come up with some type of question based on that. And when we come up with something that we're interested in, like for example, like maybe I'm sitting here recording this video with you guys and all of a sudden I hear a loud noise from the other room. Well, that loud noise I took in as an observation. Based on that observation, I might make up a question that's like, oh, I bet you that's just my cat, fooling around in the closet or something. So I may have this question about it, And so it's kind of piquing my interest, and so I formulate this question. Maybe I want to do a little research and I want to find out about it. It depends on what it is. Now, usually in the science world, before you continue moving any further, you do some type of research. This is an important step. You need to kind of check in to see what relevant research has happened before, if anyone has this question already. And so by doing that, you need to make sure you're using a reliable source, such as scientific journals, peer-reviewed articles, and any sources that are trusted online, like a .gov, .edu, etc. So the next step in our process here is a hypothesis. So once we have a question, we've done some research about it, we want to come up with a hypothesis. Now, a hypothesis is usually kind of an educated guess, is a way that some people describe it. It is a tentative explanation for the observation that you have seen, heard, tasted, felt, observed, but it needs to require testing to validate. So in biology, we think about kind of hypotheses coming from how the body works, biological systems, things like that. Some other things that might play a role here are imagination, intuition, chance, logic, scientific theory, previous scientific results, and experiences. Now, a lot of times when we write a hypothesis, we use if and then. So if something is, then something is. Like, so for example, I heard that noise in the other room. Oh, that must be my cat. Could it be my cat in the closet? If my cat is in the closet, then surely, you know, he made all of the noise because something fell. Now, thinking about kind of characteristics of a hypothesis, it needs to be testable. So we need to be able to test it. We also must be able to falsify it. So meaning that we could possibly prove it false based on a set of things. It needs to be consistent. It needs to be useful. And it clearly states a relationship between the defined variables that we have. Now, defined variables need to be easy to measure. In terms of measurement, what we can measure, what can we collect, because we need to collect data here. So sometimes we can do this by what we call inductive reasoning, and this is a way that we construct a hypothesis, which is kind of a logical process. We look at the scientific instances and general conclusions and kind of essential tools to understand the world. Like, so when I just made up my hypothesis about my cat possibly being in the closet, the one making the noise, those are essential tools from the understanding of the world that I have. So I'm using kind of inductive reasoning. Deductive reasoning is kind of making a prediction or an outcome. Again, using if and then statements. Now, again, everything needs to be testable, so we need to have an experiment. We need to have a process in which we're going to experiment our hypothesis and answer the question that we've come up with. Now, in our experiment, we have to have experimental groups and we have to have control groups. So control groups are basically groups that we're comparing everything to. They are staying constant, or what we think of as kind of normal or typical for the experiment, like a placebo, for example. Now, experimental groups have variables that are either dependent or independent variables. And those are things that are important and are going to change things. So dependent variables are always something that are measured. We are counting, we're recording and measuring. So we can take some kind of quantitative data from it. Now, independent variables are something that is attempting to change this dependent variable. So something that might try to change or manipulate the outcome. So independent variables are manipulators. They want to change what's going to happen to the dependent variable. The dependent variable is something that you are always measuring. So kind of going into a little bit more on that, a dependable variable, it can be quantitative, so we're measuring it, numbered, counting, etc. But it could be qualitative, but this is not necessarily measurable, but it's something we're counting. We're talking about the gender, the sexuality, the race. So we're actually still looking at qualities, and we can still put a data number to that. So it's still very similar as far as we are measuring something. The control group is that group that we need to have that controls the outcome. They are the comparison group, the group that stays the same. No matter what they do, they're staying the same. So for example, let's say we are testing a new drug, for example, and some of the group is control and some of the group that we're testing is experimental groups. Everybody gets a tablet that looks exactly the same, but the ones that are actually in the experimental group are getting the new drug. The ones in the control group are just getting a placebo. And so their symptoms and signs and things shouldn't change. So we would use whatever they come out with as a control comparison. So again, with our COVID testing right now, I'm sure there's a group of folks that are just getting injected with a vaccine, which is actually a placebo in the group. Now, we're always concerned with primary sources. Now, primary sources are researched, reviewed in the scientific community, are what we call peer-reviewed. These are journal articles. When I say articles, that doesn't mean like, I saw an article in the paper. That is different than a journal article. Or I saw this wonderful article on social media. Well, most shit that's on most social media is shit, okay? Not all of it, but a lot of it is. You have to really look back at what was the source. Who did this study? Was it looked at by other people? Was it peer reviewed? Primary sources are references. Nothing that we put on our Play-Doh page has not Play-Doh, Moodle page, excuse me, has a lot of references that are primary sources. We might have a few journal articles here and there as we go. Those would be primary sources. Secondary sources is most likely what we see. Books, news reports, social media, advertisement, newspapers. All of those are secondary sources, and those are published every day. And sometimes their information is backed by primary sources, but you have to look for that, okay? Some of that stuff is not peer reviewed. It's just kind of spewed out there. Some of it has very jaded views. The media has a lot of jaded views, left and right, right or wrong, whatever, but just be aware that not everything you hear is correct. Now, I have a video that I attached separately that kind of goes through this little depiction here of an actual cell phone and a scenario where we are looking for how we use the scientific method in every day. Now, one example I might use if we were going to class and we were meeting is maybe we need to get to class and we go out to get to the car. But before we get to the car, we have to leave the house. And before we leave the house, we need to find our keys. And so all of a sudden, we can't find our keys. And so you're like, I'm looking everywhere and I'm observing that I cannot find my keys. So I might very well say, oh, I left my keys in my backpack. I must have left them in my backpack. If I can't find my keys, they have to be in my backpack. So I just made a question and a hypothesis. The next thing I would do is test my hypothesis. I would actually go to my backpack and look for my keys. If I did not find my keys, then I'm revisiting my question, a hypothesis. Well, if my keys are not in my backpack, then they must be on my desk in my room. And so then I would test that experiment by going to my room, looking on my desk, and let's say this time I found my keys. So by doing the experiment, I collected data, which were my keys, and I have proved myself correct afterwards that I have my keys and I'm ready to class. We do this all the time without thinking of the fact that we're going through all these steps. Maybe you can't find your cell phone. Maybe you need to start your car and the car doesn't start. We go through the scientific method every single day in our lives, multitudes of time. However, we do it in a very quick fashion, and it's not, the stakes are not very high if we're at fault and our hypothesis is false. Sometimes in bigger studies, obviously, we are in higher stakes scenarios, like looking for a vaccine for COVID.